So we're going to be performing just a very, very basic static analysis with Ghidra, which is a reverse engineering framework. We're going to start off by actually creating a new project. Once we've created that new project, we can then import a file. But you also got to understand what's going on in the graphical user interface. So the first thing we have here is a tool chest. The tool chest is a collection of tools available in the software. The green dragon icon is the code browser, and it's Ghidra's primary tool for binary analysis, which opens the executable file and allows you to analyze it. The other icons represent additional tools such as the symbol table manager and data type manager. We've got our active project. So the one we have here is in-class demo. A project in Ghidra serves as a container for all files and analysis related to the particular task. The lab2.exe, which is the one we imported here, is the file that's being analyzed. And we've set it to be a portable executable file, which is most likely a Windows binary. We've imported the file into the Ghidra project, and then we're going to analyze it. This view also allows us to switch between hierarchical organization, enabling you to handle multiple files at once, or we can move into table view. There's also a filter at the bottom of the project panel. The filter lets you search for files or artifacts within that project. Now, I already talked about the tree view and the table view, but let's talk about it a little bit more. Those tabs let you switch between different organizational structures for the project and displays the project and its content hierarchically, which we currently have selected, and then table view, which provides a tabular representation for quick overview. And we can run our tools. So the green dragon is the one we're going to be running, and that tool, in the running tools section, it will tell you which ones are open. We also have a status bar where we have like ASCII strings. Ghidra may have extracted readable strings from the binary during the import, and apply data archives. So Ghidra has completed applying standard data types to the binary, and call conversations refers to the initial call analysis during the import. We then double click on the file in order to analyze it, which will open up the code browser. And then we're going to actually perform or begin the analysis process. Okay, now that we've started the analysis, we've got some things to look at here. So we have the program tree, which is a hierarchical representation of the binaries, components, and sections. Each entry corresponds to a part of the executable. We have the headers, which contains metadata about the file, such as format type, so PE for Windows, ELF for Linux, and the architecture, such as x86 or 64, an entry point, and section details. We've got the text, the code section where the program's executables instructions reside, and we got our data, which is a read-only data section typically containing constants, strings, and function pointers. We've got .data, which the initialized data section where global and static variables are stored. We've got pdata, which contains information for exception handling, functions, pointers for structured exception handling in Windows. We've got .reloc, which is the relocation table, which is used to adjust addresses if the executable is loaded at a non-preferred address in memory. We've got debug data, which may contain symbols for debugging information if the binary wasn't stripped during compilation time. We've got our symbol tree, which categorizes the symbols identified within the binary, in our case lab2, into various groups, aiding static code and malware analysis. So we've again got our imports, which lists the external functions or libraries that the binary uses. This section often includes API or system calls, which can reveal functionality. We've got create file, send, or WinX. We've got our export sections, which shows functions or data the binary exposes to other programs. Rarely used in malware, but custom malware libraries or DLLs might include exports for modular functionality. We've got our functions, which displays all the functions identified within the binary. Ghidra categorizes user-defined functions, system functions, and imported functions here. Analysts can explore each function to study its behavior. We've got labels, which represents addresses and points of interest identified during analysis. It can be custom created to mark important areas such as key instructions or data read. We've got classes, which lists classes if the binary uses object-oriented programming. For malware, this can reveal structured code or anti-analysis mechanisms written in higher languages such as C++. We've got namespaces, which organizes symbols into logical groups, typically based on their originating library or module, useful for separating system libraries from custom logic. We've also got our data type manager view, which is used to manage and analyze data types identified or defined in the binary. So the data type manager organizes and displays data structures, types, and headers related to the analyzed binary. We've got built-in types, which includes primitive data types such as integer, byte, and void, provided by Ghidra for analysis. With lab2.exe also has custom data types and structures extracted or defined during the analysis of the binary. We've got our header files, simulated or extracted headers representing standard libraries or operating system APIs such as standard lib or WinBase. We've got custom types to include specific structures or types like image runtime function entry or GUID, commonly found in PE files or Windows executables. We've got our listing view, which in Ghidra specifically showing the PE file headers of our current Lab2 binary. The listing view is a disassembled representation of the binary, showing raw bytes, interpreted values, and cross-references. At the start of a PE portable executable file, the MZ header is visible. MZ indicates that the file is a valid DOS or Windows executable. The MZ header is the first part of the PE file containing metadata about the executable. Then we also have the decompiler view in Ghidra, which translates low-level assembly code into more human-readable C-like format. The decompiler view is a core feature in Ghidra that simplifies the understanding of binary code by generating a high-level representation. The function fun 140001450 we were analyzing earlier, and its parameters and local variables are displayed. The use of generic names such as undefined param1, param2 indicates that the Ghidra has not yet resolved the function's data types or parameters. We also have a search function, which we can use for searching the memory or searching strings and text within the application. We can use this to find things like communications with a C2 server, writing files, either config files or log files, and so on.